In this video, I'm going to be proving the quotient rule to you. I'm going to be proving it using the definition of the derivative. So this is kind of intended for when you're just starting out at the beginning. You don't have tools like implicit or logarithmic differentiation at your disposal. We just are going to show this directly. So just to remind you about the definition of the derivative, it's the limit of rise over run as run goes towards 0. So for a given function y of x, its derivative is the limit as h approaches 0 of y of x plus h minus y of x. That's rise. How much did y increase by when you bumped up x by a little bit? Divided by the run, which is h. And we're going to consider what happens as run goes to 0. So if I'm going to try to, show this, I'm going to need to turn this into that limit definition. So that will give me the limit as h approaches 0 of this thing with x plus h plugged in, minus this thing, well, just minus this thing, divided by h. And rather than writing this as, lots of layers of fraction, I'm just going to multiply by 1 over h. Okay, now, much like when I was proving the product rule to you, I'm going to have to add a clever form of 0. Okay. Actually, I think maybe just looking at it, I'm not working off any notes right here. I think what I want to do first is going to be write this as a single fraction. So get a common denominator. So I'm going to do that. All right, there you go. So I've written this as 1 fraction times 1 over h, right? Just took this and multiplied by g of x over g of x, and took this fraction and multiplied by g of x plus h over g of x plus h. Okay. And now what I'm going to need to do is add in a clever form of 0. Okay, so I'm going to be adding and subtracting f of x times g of x. And I think I'm going to subtract it first and then add it back, just like in the product rule. So there you see that I've added f of x, g of x, and I've subtracted it. So really, in total, I've added 0 to the numerator, so I haven't really changed the numerator, therefore I haven't changed the fraction. Also, notice that I took this h and I just put it in there because I was starting to run out of room. Now, what we're going to want to do is kind of, first of all, I'm going to actually just factor out the 1 over g plus g of x plus h and the g of x, both in the denominator. I'm going to move those out in the front. So this is going to be the limit as h approaches 0 of, okay, well, I'm going to have 1 over g of x plus h g of x. This is where we're going to get the g of x squared in the denominator. Okay, and then I'll have left, well, what I'm going to do is, what do I have in both of these first two terms? Okay, I'll be left with, I'm going to split over this addition. Okay, so I'm going to have the sum of two fractions. And in the denominator of both of them, I'm just going to have h, right, because I've already dealt with these, pulled them out, dealt with them separately. And what am I left with over here? I have, let's see, I can factor out a g from both, so I have f of x plus h minus f of x. And then I've got a g of x on both of those. Okay. Plus, then over here, what do I have in common in both of these? I have an f of x, so I'll just say, well, doesn't look quite right, to say I have a g of x minus g of x plus h. What I want to say is I want to say minus here, because I know I've got that negativity in the numerator of the quotient rule. So I'm going to kind of factor out a negative. And I'm going to say minus g of x plus h minus g of x all divided by h. And I still have this f of x over here. And then what I want you to notice is, well, up to the definition of the derivative, well, this is the derivative of f, and this is the derivative of g. And as h goes towards 0, this is going to become g of x, right? I have 2 copies of g of x. And so I have 1 over g of x squared multiplied by f prime of x from this one times g of x minus, this is g prime of x, and f of x. Okay, to put this all together, this is equal to, and to write it as I had written it in the statement of the theorem, g times f prime minus f times g prime. Oh, starting to run out of room here. All divided by squared. Which is, if I take a second to zoom out, that is as far as I can zoom out. I don't know. Okay, maybe I'll just do a little bit of that. Yeah, which, if I zoom all the way out, is what I had set out to show in the first place. So this is the quotient rule, and this is why it works using the definition of the derivative.